Okay. We will now talk about capacitors connected in series. Now, what is the meaning of connecting capacitors in series? Well, here I have connected 3 capacitors in series. I want you to learn how capacitors are connected in series. Now, this capacitor has a capacitance C1, this has a capacitance C2, and this has a capacitance C3. Now, I have placed them in such a way that the positive of the first capacitor, negative of the first capacitor. The negative of the first capacitor is connected to where? The positive of the second capacitor. The negative of the second capacitor is connected to the positive of the third capacitor, and the negative of the third capacitor is connected to the negative end of a battery. The positive end of the capacitor, the first capacitor, is connected to the positive end of the battery. Now you can see there is a closed electric circuit here that contains 3 capacitors connected. Now watch or listen to the terminology I use. 3 capacitors are connected in series, and that series combination is connected across a battery. Now, what is the function of a battery? What does the battery do? We will talk more about it in the next lesson, but the function of a battery in an electric circuit is to provide the necessary potential difference. You see, electric charges can move only if there is a potential difference, and the potential difference necessary for moving the electric charges are provided by this battery. Now, in this case, when the positive of the battery is connected to the positive of the first capacitor, electric charges move from the battery so that this plate of the capacitor, this plate of the capacitor receives a positive charge. Now, I'm going to disconnect it because the charges are, and now, if this receives a positive charge, then this will be receiving a negative charge. Now, if this receives negative charge, the one that is connected to the, because this is connected to the next capacitor, these negative charges are drawn from this plate, leaving this plate positive. You see that? So this becomes positive, means this will become now negative. Now, this is connected to the terminal of this capacitor. So what will be the polarity of this? That will be positive. That means each of this capacitor will have a positive plate and a negative plate. So this is the positive plate, this is the negative plate. This is the positive, this is the negative of the second capacitor. This is the positive and this is the negative of the third capacitor. So how are they connected in series? The negative of the first capacitor is connected to the positive of the second. The negative of the second capacitor is connected to the positive of the third. And the negative of the last and the positive of the first comes back to the battery. Now, what does the battery do? The battery provides a certain amount of charge Q to the first capacitor plate. Now, that means if this has a charge Q, then this will have a charge negative Q. If this has to have a charge negative Q, that means the plate that is connected to that of the second capacitor will then obtain a positive Q. If this has a positive Q, the other plate for the same capacitor will have negative Q. Now, if this has negative Q, the plate that is connected to that of the third capacitor will have positive Q. You see that? So, the amount of charge on the first capacitor plate is positive Q, other plate negative Q. This is positive Q, negative Q, positive Q, negative Q. And now, this is a bike battery, and most of you know it is 6 volt. So I have applied a potential difference of 6 volt. What does that mean? Volt means joules per coulomb. In other words, when this battery is connected, the amount of work done to move 1 coulomb of charge from one end of the circuit to the other will be 6 joules. 6 joules per coulomb. So if I want to move 1 coulomb of charge now through this system, the amount of work done for 1 joule will be 6. The amount of work done for 1 coulomb will be 6 joules. That's the meaning that the potential is V. Now, that means the amount of work done, you remember the charge has to go through capacitor 1, then capacitor 2, then capacitor 3. So this total work done is actually divided into 3 parts. 1/3 of the work is done in order to transport that charge across the first capacitor. Then a certain amount of work is done to transport the charge across the second capacitor. Then you need to do work to transport the same charge across the third capacitor. So the total amount of work done is a measure of the work done to move the capacitor. The total amount of work done is a measure of the work done to move the charge across the first capacitor plus the work done to move it across the second capacitor plus to move it across the third capacitor. That means the potential difference now across each of these capacitors, if you add the potential difference across this, add it to the potential difference across the second capacitor, add it to the potential difference across the third capacitor, it must be equal to the total potential difference. Now that means when capacitors are connected in series, they divide the total potential. If the total potential is 6 volt, if each of these capacitors is the same, then each will have 2 volt across each of them. The potential difference across the first one will be 2 volt. The potential difference across the second one will be 2 volt. The potential difference across the third one will also be 2 volts. So that the total potential will be V1 plus V2 plus V3. So let me repeat that again. If a parallel network of capacitors are connected across a battery that provides a potential V, I'm not going to give you a number now. If the total potential is V, then that total potential will be divided among the 3 capacitors. So that if the potential difference across the first capacitor is V1, the potential difference across the second capacitor is V2, and the potential difference across the third capacitor is V3, then V1 plus V2 plus V3 will be equal to the total potential provided by the battery. Okay, now let's write those things down and obtain an equation for the total capacitance. If 3 capacitances are connected in series, what is the total capacitance in the circuit? Alright, let's look at that and we will now write that down. As I showed you, we have 3 capacitances of capacitance C1, C2, C3 are connected in series and the combination is connected to a battery. You see, a battery has a positive end and a negative end. The battery provides a total potential V, and I told you that this total potential will be now divided among the 3 capacitors as V1, V2, V3, so that V1 plus V2 plus V3 will be equal to V. Alright? And so the total potential will be divided so that the potential difference across C1 will be V1, across C2 will be V2, and across C3 will be V3 in such a way that V equal to V1 plus V2 plus V3. But as I explained to you, if a total charge Q is taken from the cell, that charge Q is on the first capacitor plate. If this gets a positive Q, then its other plate will have a negative Q. The second capacitor similarly will have a Q, a negative Q, Q, a negative Q. What that means is each capacitor has the same amount of charge, and that is equal to the amount of charge removed from the battery. You see that? Each capacitor will have the same amount of charge Q, and that is the total charge that is removed from the battery. So the total potential gets divided, but the total charge remains the same throughout that circuit. This is an important characteristic of series connection. When capacitors are connected in series, the total potential divides among the capacitors, but the total charge will remain the same throughout the circuit. Therefore, you can see if Q is the amount of charge, amount of positive charge on capacitor 1, then it will have a negative Q on the negative plate and a positive Q on the second capacitor and negative Q. Similarly, positive Q will be on the positive plate of the third capacitor and negative Q on its negative plate. When capacitors are in series, all of them will have the same charge. The same charge Q, which is the total amount of charge that is removed from the battery. So, this is the potential equation, V equal to V1 plus V2 plus V3. Now, let's divide this equation by the quantity Q, because Q is the same for all. Let's divide this equation by Q. Dividing means divide each term. So that will be V divided by Q equal to V1 divided by Q plus V2 divided by Q plus V3 divided by Q. Well, I hope you remember the fundamental equation of the capacitance, which is C equal to Q over V. Is that right? That is the fundamental equation for capacitance. Capacitance is Q over V, where Q is the total charge and V is the total potential. Therefore, can you tell me what is this V over Q equal to? If Q over V equal to C, what is V over Q equal to? V is the total potential and Q is the total charge. Therefore, V over Q must be 1 over C. Is that right? Yes. So, because Q over V equal to C, then V over Q must be equal to 1 over C. And what will then be V1 over Q? V1 is the potential difference across the first capacitor and Q is the charge in it. Therefore, V1 over Q will be 1 over C1. There you are. Similarly, V2 over Q will be 1 over C2. And V3 over Q will be 1 over C3. So what does this equation now become? It will become 1 over C equal to 1 over C1 plus 1 over C2 plus 1 over C3. And this is the expression for the total capacitance. Look at this. This C represents the total capacitance. When three capacitors of capacitances C1, C2 and